today's session, we're going to discuss about geological characteristics or the studies to be done for selecting a reservoir. And when you're talking about dams and reservoir, both of them goes together. The dam that produces a large area which would be storing the water, and the water where it is stored, that we call it as the reservoir. So while selecting the dam, we also need to look into the site for storage of this water. And the parameters of selecting the dam, parameters of selecting the reservoir, these all things actually goes together. But while for the convenience of understanding the things, we are taking it separately. So when you're talking about the dam and the reservoir, there are a number of different, similarly as we discussed about the dam, there are a number of different reservoir types. Such as for the storage or conservation reservoir, or maybe a flood control reservoir, or maybe a distribution reservoir. It's all for what purpose we are going to use that reservoir area. There are a few terminologies which are associated with the reservoir that we call basically the pool level. That is the design level up to which the reservoir shall be full of water. We can construct the water while doing the construct the reservoir, or while doing the reservoir, considering the reservoir, we will be keeping up to one level where we can store the water. So these are the terminologies where maximum pool level indicates that the level at which we can store the maximum water. So if any water which goes above this level, it will overflow the dam. It will flow over the dam, and above which we cannot store the water. And the second one, it is the minimum pool level. That is the level at which the water can be used. So the water which is below this level is not useful. So the water which is stored below this pool level, that we cannot use. So that part we put it as the minimum pool level, and this is the normal designed level of water what it is planned for that particular reservoir. That is the normal pool level, and this maximum pool level only achieves when the water is flowing in the flooding seasons, or in a high high amount of water which is coming in the season late, not normal. When these different levels are considered, so there are storage details. So the storage, what it is in between the minimum and the normal pool level, is called the useful storage, that we use for different purposes. So for hydropower, for wind irrigation, for any of the purposes we use that water, we call it as the normal useful storage. And the water which is below the minimum pool level, that is not of use, we call it as the dead storage. And the water which is between the normal and the maximum pool level, which is only seasonally or in the high flooding seasons, the water is going to get into that level. We call it as the surcharge storage. This one more small terminology is that the reservoir yield. So the reservoir yield is the volume of water can be drawn from a given reservoir in a certain interval of time. So that how much water can be extra used from that reservoir, that actually is mentioned in the terms of reservoir yield. So these are the basic fundamental things or fundamental terminologies which are associated with the reservoir. That is not our primary concern at this point, where we are discussing about the geological characteristics of the site. So we are basically going into the aspect where what kind of geological characteristics are required for the reservoir. First one, it is a topographical characteristics. So when you are talking about the topography, when we discussed about the dams, we said that the dams will require, it is easy to construct a dam which is having a narrow valley, where the connections what you need to make from one side of the valley to another side of the valley would be minimum. That would be again the situation for the construction of dam. But when you talk about the reservoir needs a large amount of area to store the water. So the valley which is extended for so many kilometers of upstream, and if it is in a V shape or a U shape, so that would be a favorable condition for the reservoir. But a very really unfavorable condition is a valley like very flattened valley, almost horizontal kind of valley. So that is not a very favorable condition for the construction of a dam. So whenever we look into the topographical characteristic that has been studied by the topographical maps or in the geological maps, where the topography of that area can be interpreted, and that interpreted topography will see that how much area can be used for storage of this water. Based on that, we decide the height of the dam, and all both of them together, which actually decides the location of the dam. So when the dam is constructed, automatically the upstream side of the dam is going to be the reservoirs. Now, when you talk about the second thing, that is the groundwater conditions. So groundwater conditions we discussed briefly, that is the water which is present below the surface of the earth. And if you remember the terms what we discussed or the characteristics we have discussed, the groundwater usually follows the topography of the area. So when we take the elevation, that also depends on the porosity and permeability, the amount of recharge, number of other parameters are depending on the groundwater. But when we look at groundwater characteristics for the consideration of a reservoir, the best possible condition is that this is the level of water storage. Okay, so how much level we are going to store the water. So and the upper level what we show it is the water table, top reservoir level TRL. So that is comparatively in a lower level than that of the height of the water table. So top reservoir level is below the height of the water table. So as a result, this is having the hydrostatic head. So some amount of water can be contributed to the reservoir. At least it will not take up the reservoir water to the groundwater, because the water is already saturated and the height of this water table is much above the height of the top reservoir level. So this is the very favorable condition when we are talking about the water table of that region. Now in the second case here, if you see, this is the dam what I am going to construct, and this dam is going to fill with water, and this dam is going to store the water on the reservoir. But when it is storing, so this much depth of the rock above which we are considering the reservoir, constructing the reservoir, is a dry soil which is not saturated with water. As a result, what will happen? The water from the reservoir will start saturating this rock. Okay, and that reservoir will saturate the rock, and this is actually going to have to imagine in a three-dimensional way. The entire basin where this water is going to store is going to consume the water from the reservoir. So this is a huge amount of loss which is going into the groundwater. It will recharge the groundwater, and this groundwater will be extracted through some other place, or it may move, or it may travel within the rock, and the movement of water will happen below the surface. And it is not the purpose where we constructed the dam. The dam is constructed to store the water, and the water is going to be used for some purpose, but it is now losing into the groundwater. So this is not a favorable condition for the consideration of a dam. Okay, now the third level is that the water table and the top reservoir level is at almost same height. Both of them goes in a same height, and this condition there is no major contribution to the groundwater, so this is not happening. And the water which is going to reservoir, so these two conditions are not happening. So this is no loss, no gain. So we are not getting much benefit out of the water table, and we are not also going to lose the water table. So this is not a bad condition, or we can be a good condition, but this condition is really going to be a bad situation for considering the area for a reservoir. Okay, so these are the basic characteristics of the reservoir in terms of the groundwater. Now the next thing, it is the consideration of the reservoir and looking into the other parameters like permeability, structural constitutions, and the trend and the rate of weathering. Permeability we have discussed. What is permeability? Permeability is the amount of connected pore spaces in the rock. So how much amount of water can be transported through a rock is what we call it as the permeability. Now this permeability can be a textural permeability, that the sandstones is having voids in that, so that can be act as a permeability, or it can be a secondary permeability also. So this secondary permeability is what we are talking is such as in the situation 1 here, there is a limestone, and these limestones are having cracks on that, and the water which is stored on this the reservoir now started getting into these cracks, and it started moving on these cracks, and it is escaping from the reservoir. So there is a huge amount of loss of water through this limestone. Okay, so this is a really unfavorable condition, but we have constructed the dam for the purpose of storing the water. Now the water is leaking through, and this we will realize at the point after we construct the dam. And if you find out that the water what I am going to store on this, there are a number of cases which happened actually. This is not a something theoretical only. There are few kind of dam sites this actually happened. They started storing the water and realized the water is not going to store in the reservoir, because there is some connected cracks or a fracture or a joint to something through which the water is going to escape. So that is one condition where in the case of a limestone terrain. Second condition is here where the water is stored. So this is the dam. This is the orientation of the dam, and below this rock types, so these all rock types have been studied, and below this rock type there is a paleo channel. Paleo channel is nothing but when there is a river which flows, so there will be number of layers of sediments which will be filled. So there will be a small channel. It was once upon a time the river was flowing, but it got filled by its own sediments. Now this is not seen or it is not visible, but at a time it will come that the water which is stored in this reservoir may get into this channel and it will escape. You must have heard about the story of river Saraswati. Once upon a time we believe that is the major river which was flowing on this in this northwestern part of our country, and now we don't have any evidences of that stream. That stream has completely vanished. It is not having any traces of that stream, because the sediments which it transported, which carried, and it covered the river, and that river is now not seen. So that channel which was flowing once upon a time in the past, which is not seen these days, we call that the buried channel as a paleo channel. So that kind of paleo channels are very common in the case of a river system, where some channels will be there, and it may be filled with the sediments or with some sediments of the river, but need to be identified. So this is a real story that one dam construction in India itself. So they faced this issue, this paleo channel, and they detected this paleo channel when started storing the water, and there are a number of treatments possible for this. It may need to be plugged all the area. It has to be completely detached from the other surrounding area. So, but it is an expensive affair. It is not easy as was seen. Or you may be grouted completely. All this channel may be filled with cement, and it has to be stopped the leakage of water through that. So this is another condition, some kind of water leakage through the paleo channel. So the other thing that it is a structural disturbance. Structural characteristics also will create the trouble. For example, this is the dam which is storing water, but as you see, there are a number of joints. This we call it as joints, and there is few faults also. So at the point when water reaches this point, this height, fault, it is a broken surface. So through which the water can escape, it will flow away, and these joints which are in those rock, that also will take the water from the reservoir. So it is actually causing the loss of the wastage of water through these different structural features. Okay, so these are all different parameters we have to look in. So the ideal condition is that there should not be any paleo channels, there should not be any subsurface cracks which can be easily erodable by the water, like the limestone which can do. That kind of rock type should be avoided, and we should see and properly map the availability of faults or the joints which are there in the rock. And if there is a fault, either you plug this or fill this, then only do the area for the construction of the reservoirs. So the primary thing is that realizing this these things in the field before you do the construction of a dam and the reservoir. So if you realize that there is a leakage of water through some weak plains after the construction and after the storage of the reservoir, then again you need to empty the reservoir, then you have to go on and again all processes of construction. So that is all going to be a very difficult process, because construction of a dam is not that much easy as if we pursue. Okay, so the final or the last point of the construction is the trend and the amount of weathering. What does this mean? Trend and amount of weathering. For example, if I take this is the rock, so this is the surface of the rock. Okay, now this is a hard rock, and this hard rock is exposed to the sun and the weather condition for thousands of years. So for example, if I take our Narmada river, where the dam constructed, Sardar Sarovar Dam is constructed, this Sardar Sarovar Dam, before construction of that dam, that rock which is now under the water was exposed to sun and the natural surface conditions for millions of years, because we know, as per our understanding, that rock that is a basalt is formed at around 64 million years before. So that means the rock was exposed to the sun for around 64 million years. Let's take around 60 million years. So the 60 millions of years, once the rock is exposed to sun, it will create a weathered profile. The surface will get loosen its strength, and the original hard rock will be much below, and the surface will be getting a weathered profile. We call it as the weathered profile. So the thickness of this weathered profile is very important to understand, because when not only in the reservoir area, the entire catchment area, that how much is the thickness of the weathered profile, because all this weathered profile, weathered soil or the rock which is going to flow to the reservoir as a result of a rain or the surface runoff, so that all materials are going to come and deposit in the reservoir. So when this huge amount of material which comes to the reservoir, it is going to reduce the capacity of the reservoir. So it will fill the reservoir once, if you are not taking proper care and if you are not understanding the actual characteristics. So we need to remove the silt. So siltation is the process which is going to happen. So we need to remove the silt well before or we should also know that how much amount of weathered profile is there on the entire drainage basin, and how much amount of silt or other materials can come to the area.